Welcome. Today, we're diving into the chemical characteristics of RO purified drinking water. We'll explore what makes this water unique, how the purification process changes its composition, and why understanding these details matters for health and safety. Let's get started with Dr. S.K. Singh's insights on this important topic. Let's start by understanding what reverse osmosis purified water really is. It's water pushed through a special membrane that filters out most dissolved salts, heavy metals, and even tiny contaminants like pesticides and microorganisms. Unlike natural mineral water, RO water usually has very few minerals left, unless they're added back in later. Our chemical evaluation aims to confirm the water's safety, check mineral levels, ensure it meets standards, and track how well the treatment works. For example, water with high mineral content can be purified down to much lower levels through this process. Let's look at what a well-operated reverse osmosis system typically produces. The water usually has a pH between 6.8 and 7.5, close to neutral, which helps control corrosion. Total dissolved solids, or TDS, range from 40 to 100 milligrams per liter, reflecting mineral content. Conductivity sits between 60 and 150 microsiemens per centimeter, showing ionic concentration. These key parameters, along with hardness, alkalinity, chloride, sulfate, nitrate, and fluoride, all tell us about water quality, safety, and taste. Together, they paint a clear picture of the water's chemical balance. Let's talk about what happens to minerals during reverse osmosis treatment. RO effectively reduces mineral content, which improves water purity. But here's the thing, essential minerals like calcium and magnesium mostly come from our diet, not drinking water. Sometimes, adding minerals back in a controlled way can actually enhance taste and help keep the water stable. For example, after RO, we might add food-grade calcium and magnesium to make the water taste better and prevent corrosion, all without sacrificing safety. Let's look at a real-world example of reverse osmosis in action. Feed water with arsenic levels around 0.04 milligrams per liter can be reduced to less than 0.005 milligrams per liter after effective RO treatment. That's a huge drop, but it depends on the system's design and proper validation. RO membranes also remove a wide range of other contaminants: lead, cadmium, mercury, even nitrates and fluoride, with removal rates often above 90%. It's a powerful method for cleaning water. When we treat water with reverse osmosis, the result is often very pure, but also quite soft and slightly acidic. This low alkalinity and hardness can make the water corrosive to pipes and systems downstream. That's why post-treatment is often necessary. We have several options: calcite or dolomite media, food-grade minerals, carbon dioxide adjustments, and pH correction systems. These methods improve taste, reduce corrosion, boost calcium and magnesium levels, and stabilize pH, for example. Raising pH from 6.2 to around 7.2 makes the water more balanced and pleasant to use. When it comes to chemical testing and quality control, we rely on a range of analytical techniques. These include methods like ICP-MS and ICP-OES for elemental analysis, ion chromatography for separating ions, and UV visible spectrophotometry to measure light absorption. We also use flame photometry, titrometric methods, conductivity, and pH meters to keep a close eye on water quality. Routine monitoring involves testing common parameters like pH, conductivity, total dissolved solids, hardness, and key ions such as calcium, magnesium, sodium, and potassium. We also check for chloride, sulfate, nitrate, fluoride, silica when relevant, and heavy metals to ensure safety and compliance. When working with reverse osmosis systems, we often face a set of common issues that can affect water quality. High total dissolved solids, or TDS, usually point to membrane damage, so integrity testing and replacing the membrane are key steps. Low pH often means low alkalinity, which we can correct through controlled remineralization or pH adjustment. High hardness might come from scaling or membrane bypass, so reviewing pretreatment and inspecting membranes is essential. Elevated nitrate levels suggest reduced membrane rejection, so assessing membrane performance and operating pressure becomes critical. Throughout, we must meet strict regulatory standards for pH, TDS, nitrate, fluoride, heavy metals, and microbiological quality to ensure safe drinking water. Reverse osmosis, or RO, is a powerful process that cuts down total dissolved solids, hardness, heavy metals, nitrates, fluoride, and many other contaminants. The result: high-quality drinking water that's safe and reliable. But to keep it that way, we need to monitor key chemical parameters, things like pH, conductivity, hardness, and trace metals, using validated methods. Post-treatment steps like remineralization help improve taste and stability. Quality assurance means routine testing, online monitoring, maintenance, and careful record-keeping. Following international standards ensures the water meets the highest safety benchmarks. If you found this presentation useful, please like, share, and subscribe. Don't forget to turn on notifications for more expert insights on reverse osmosis technology and related fields like water quality, food safety, and environmental engineering. To wrap up, reverse osmosis gives us drinking water with very low levels of salts and contaminants, thanks to its high rejection efficiency. But ongoing chemical monitoring is key to making sure treatment stays on track, meets regulations, and keeps water quality consistent. And when needed, controlled remineralization can enhance taste and stability without sacrificing safety. That brings us to the end. For any further support or questions, please don't hesitate to reach out. Thank you for your time and attention. It's been a pleasure sharing this with you. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.